In this video, we'll complete a short exercise that will demonstrate how to use several key features of mPanel. First, we're going to find the correct membrane shape for a barrel vault or saddle-shaped surface, which is technically called an anticlastic shape, and then we'll panel that shape. We'll work from a simple boundary frame which I created earlier in Rhino. Let's move it around a little bit. As you can see, it is made of 2 lines in black and 2 arcs in cyan. Now we'll add a basic arbitrary shape mesh onto this frame. The mesh represents the surface of the fabric. At this point, we don't care about the shape of the mesh, we just need a starting point, and we'll adjust the shape later. To add the mesh, we'll use the mPanel Model Builder. Before using this tool, however, we need to set the options. Right-clicking on the mPanel Model Builder tool will bring up the options window. Click on Draw Edge Mesh, and under Mesh Settings, we see the Mesh InSurf and the Mesh ImSurf. The InSurf and ImSurf are the number of threads in the mesh, which determine the quality of the mesh and the number of panels. For this model, we'll go with the default settings. Click OK to close the options window. Now click on the Model Builder button. The Rhino text window, up here, asks us to select the bottom edge, now the right edge, now the top edge, and now the left edge. Now we have a basic shape mesh. We'll copy this mesh over here in order to work some more on it. Now we need to find the correct mesh shape to turn our model into a tensile fabric structure. To do this, we'll select just the mesh, and then we'll use the mPanel command Relax Fixed Edge Meshes. Relaxing the fabric is taking it towards the force balance shape it will be in when it is under an equal stress on all sides. The old mesh will be colored red, and the new mesh will be in black. We can delete the old mesh by clicking the mPanel Delete Old Object button. Now select the mesh and relax it again. Each time you relax the mesh, mPanel takes it through a run of 250 iterations towards the correct force balance shape. The correct shape is obtained when the model shows no sign of further movement when relaxing. In a simple model like this, that will generally happen with just one run of 250 iterations. We know that the relaxation is complete because the old mesh, in red, is exactly coincident with the new mesh, in black. Another way to see if the relaxation is complete is by checking the residual, which can be found in the mPanel text window. If the residual is below 0.0001, the relaxation is complete. Here it tells us that our residual is at 0, so clearly the relaxation is complete. Sometimes you may want to adjust the loft of the mesh. The loft is a term for how much the mesh is being lifted. To adjust the loft, we'll go to the Mesh Relaxation Options page, and we'll change the weft-warp stress ratio. For this example, we'll try a ratio of 2. Now we'll relax the mesh again. This time you can see how the mesh has been lifted from its old position, and the new mesh, in black, possesses more tension. Once we've created a mesh with the right shape, we need the flat panels, which when sewn together will produce that shape. We can create the panels using the mPanel Panel a Complete Mesh tool, found right here. We simply select the mesh, and then click the tool. The panels will be drawn under the mesh in the XY plane. Let's move our mesh out of the way to get a closer look at these panels. We can now delete the original mesh, and we can also delete our original boundary frame since we don't need it anymore. And when we move these panels around, we can see that they really are flat. These panels, however, clearly have some centerline curvature, especially near the edges, and that can complicate the actual panel production. Sometimes paneling across the mesh will give us better results. To try this out, we'll panel across the mesh. We do this by going to the options under the Panel Complete Mesh tool, and then we specify Panel Across Mesh. Now we'll select the mesh and run the paneling program again. This time we get much more rectangular panels that run across the mesh. And because these panels have less curvature, they will be easier to produce. Of course, this is just a quick example, but in later videos we'll describe paneling in more depth and explore other paneling options. Now we're finished with our exercise, and we've learned how to create, adjust, and panel a mesh.